Hello there. Today we'll be looking at our lesson, acid, bases and salt. Now this is a chemistry topic, so I want you to follow me closely as we go along in the lesson. Now at the end of the lesson, you should be able to define acid, bases and salts, giving examples. You should be able to describe the properties of acids and bases and their tests. You should be able to describe salts and their types with examples. And finally, you should be able to prepare soluble and insoluble salts. Now moving ahead, we'll start with acids. Acids are substances which, when dissolved in water, produce hydrogen ions as the only positive ions. There are two categories of acids. We have inorganic or mineral acids, and we have the organic acids, also known as natural acids. Examples of inorganic acids are hydrochloric acid, tetraoxosulfate 6 acid, and so on. As you have them in the picture here, we have a variety of them. We have hydrofluoric acid, hydrobromic acid, hydroiodic acid, and so on. Then we also have the natural acids and their sources. We have lactic acid found in milk, oxalic acid found in spinach and tomatoes, citric acid in oranges and lemons, malic acid in apple, tartaric acid in unripe mangoes and grapes, formic acid found in ants' sting, acetic acid in vinegar, ascorbic acid, and so on. Now we are going to look at the properties of acids. Now acids turn blue litmus paper red. They have a sour taste, and that is why when you taste unripe fruit, it tastes sour, because it contains acid. They have a pH value of 1 to 6, and their concentrated forms are corrosive. Acid neutralizes base to form salt and water only. They liberate carbon 4 oxide from trioxocarbonate and react with metals above hydrogen in the activity series to liberate hydrogen gas. Now let's look at the basicity of an acid. Now the basicity of an acid is the number of replaceable hydrogen ions contained in the molecule of an acid. So looking at the examples here, hydrochloric acid. In one molecule of hydrochloric acid, we have one replaceable hydrogen ion, which is highlighted, which tells you that it is monobasic. In tetraoxosulfate 6 acid, H2SO4, we have two replaceable hydrogen ions, so it is dibasic. In H3PO4, which has three replaceable hydrogen ions, it is tribasic. And in this particular organic acid called propanoic acid, we have only one replaceable hydrogen ion that is highlighted, so it is monobasic. Now moving along into bases. Now we are looking at the definition and its types. Now bases are metal oxides or hydroxide which react with an acid to produce salt and water only. And we have some examples right here. We have the drain cleaner and oven cleaner, which is sodium hydroxide, baking soda, which is sodium hydrogen carbonate, washing soda, sodium carbonate, glass cleaner, which is ammonia, and Na3PO4, also known as TSP. Now we're going to be looking at the properties of bases. Now bases turn red litmus paper blue. That's basically how you test for bases. They have bitter taste and soapy feel to touch. Concentrated bases are corrosive. Bases neutralize acids to form salt and water only. And bases have a pH value of more than 7, that is from 8 to 14. Now moving along, we're going to be looking at the neutralization reaction. Yes, neutralization reaction. Now this is the reaction between an acid and a base to form salt and water only. A very good example is when we react sodium hydroxide and hydrochloric acid. It will form sodium chloride and water. So this is an example of neutralization reaction. It is a reaction between acid and base to form salt and water only. Now moving along, we are going to be going into salts. Now the question is, what is a salt? A salt is an ionic compound that contains a positive ion other than a hydrogen ion and a negative ion other than the hydroxide ion. Now if you look at the examples in the pictures in front of you, we have a couple of examples here. Looking at the first one, iron 2 chloride, you can see that the purple one represents the positive ion, the metallic ion right here, and the one in the red gives us the negative ion that comes together to form iron 2 chloride. Another example is magnesium chloride, zinc chloride, sodium chloride, copper 2 chloride, copper 2 sulfate, aluminum 2 sulfate, potassium chloride. Now we are going to be moving on into the types of salt. Now we basically have 5 types. Now I'm going to start with the 3 common ones first. We have the acidic salt, basic salt, and neutral salt. Acidic salt is a type of salt that is produced by strong acid and weak base. So at the end of the day, the salt is acidic. In other words, it has a pH value of less than 7. Now a basic salt is produced from strong base and weak acid. So at the end of the day, it produces basic salt which has a pH value greater than 7. That the neutral salt is the salt produced by strong acid and strong base. It has a pH value of 7, so that's why it's neutral. It has a pH value of 7. Now we also have double salt and complex salt. Now moving along, we'll be talking about preparation of soluble salt. Now as you can see in the picture in front of you, it describes how to prepare soluble salt, especially from potassium ion, sodium ion, and ammonium ion. We prepare this soluble salt by neutralizing acids with alkali. So when acid reacts with alkali, it produces salt and water only. Now if you want to produce soluble salt with other ions, there are 3 ways by which you can do that. Reacting a metal with an acid, it will produce the metallic salt, the salt with that metal, and hydrogen gas. You can also react metal carbonate with acid to produce salt, carbon dioxide, and water. And also you react a metallic oxide with acid to form salt and water. And at the end of the day, when salt is produced, you filter it out from the solution. And finally, we'll be looking at the preparation of insoluble salt. How are insoluble salts prepared? Insoluble salts are prepared from solutions of 2 soluble salts by precipitation. And in the precipitation process, there is double decomposition reaction. Now what we have on the screen here is a very good example. Now we are trying to prepare lead 2 sulfate using lead 2 nitrate and potassium sulfate. Now these two are soluble salts. Lead 2 nitrate and potassium sulfate, they are soluble salts. So when they react together, they produce lead 2 sulfate and potassium nitrate. Potassium nitrate is soluble, while lead 2 sulfate in the color blue here is the one that precipitates out of the solution, so forming an insoluble salt. You see, you have the reaction right here and you have the ionic equation right here. So this is how insoluble salts are prepared. Now as a summary, you can see that acids are substances that produces hydrogen ions as its only positive ion when dissolved in water, while bases are metal oxides or hydroxides which react with an acid to produce salt and water only. Now examples of acids are hydrochloric acid, citric acid, and so on. Examples of bases are sodium hydroxide, magnesium oxide, and so on. Acids have a pH value from 1 to 6, while bases have a pH value from 8 to 14. They both have an effect on litmus paper. Their concentrated forms are corrosive, and they both react together to form salt and water only. And this process is called neutralization. A salt is an ionic compound that contains a positive ion other than the hydrogen ion and a negative ion other than the hydroxide ion. There are 5 types of salts: acidic, basic, neutral, double, and complex salts. We have both soluble and insoluble salts, which have different ways of being prepared. That brings us to the end of today's lesson. Now I want you to pause this video and go through the assessment to see how much of the lesson you have been able to imbibe, and I'll see you again in the next lesson.